In today's class, okay. In today's class, we'll start doing a sum, which I have told you regarding a few hours back, say 1 hour back. So let us do a sum. Okay. So everyone, please take your the note of the sum. Let me give the information in brief. So you have been asked to design is a knuckle joint. A knuckle joint, that is given that the applied force is P is equals to P is equals to 50 kilo Newton. Fine. And the material, all the materials are same. The I end, the double I end, or the pin, all are same. So the allowable stress, that is sigma YT, is equals to, for example, 380 Newton per millimeter square. Just per millimeter square. Now what you need to do is that you have to draw, you have to make it, you have to find out you have to make the design. So what will you do? First of all, number one, this will be step one. First of all, at first you will do allowable.
হ্যালো স্যার।
হ্যাঁ বলো।
স্যার একটা কথা বলছি স্যার, ওই মানব কুমার দাস আছে স্যার, আমার বাবার নাম স্যার, ভুল করে বাবার অ্যাকাউন্ট দিয়ে ঢুকে গেছিলাম স্যার।
ইটস ওকে, কোনো অসুবিধা নেই, কোনো অসুবিধা নেই, ঠিক আছে ঠিক আছে। allowable stress. So how to find the allowable stress? First of all, you need to do one simple calculations. What are the simple calculations? Sigma B, assuming sigma B, the bending stress, sigma T, the tensile stress, sigma C, compressive stress, to be same. So what will you do is you will be assuming a factor of safety. Let us assume a factor of safety to be 2. Fine. So what I can do, just to give, okay, so what I can do is I could do this one, sigma YT by FOS. So what is sigma YT? Sigma YT is 380. Divide by 3. Can anyone tell me what would be the value? What would be the answer of this one? কত হবে? কত হবে? 380 divided by 3. How much is the magnitude? Can anyone tell me? কত? What would be the value? 380 divided by 3. Sorry. I'm explaining. Sorry, it will not be 3. Sorry. It will be 2. So what would be the value? Can anyone tell me?
190.
190. Perfect. 190 Newton per millimeter square. Now let me write it in this. 190 Newton per millimeter square. Now after that, what I can do is that allowable stress, this is for one method, and this is for another, is for shear, tau. What shear? SHEAR, shear. So what I can do is tau is equals to 0. Let me zoom it. 0.5 into sigma YT by FOS. So what would be this one? 0.5 into 380 divided by 2 is equals to how much? Just give me the answer. How much will be the value? Newton per millimeter square. Okay, how much? কত আসে? হ্যাঁ
95, sir. 95.
95. Okay, that would be 95. Fine. So 95. So that is very clear that the allowable let me mark it. The allowable stress for bending, tensile and compressive will be 190, and for shear it would be 95. So we'll be clarifying it that whether the designed load is more than this or not. If it is more than that, I have to say the design is unsafe. If it is less than that, then I'll be considering the design as safe. So what I can do is, let me get back to our point. Now after that, the second step is diameter of the shaft. Diameter of the shaft. Diameter of shaft. Diameter of shaft is represented by capital D. So what happens is that as we know, the shaft is carrying a tensile load. So what I can do is that I could blindly write this one. Sigma T is equals to P is the applied load, pi by 4 into capital D square. Now you have to since we have to find out the diameter of the shaft, that means it should be under the allowable stress. So what I can do is that I have to get the value of sigma T. Now here comes from where I can get the value of sigma T. Do I have any way out to find out? Yes, we know that the sigma T is nothing but this one. As you can see, sigma T is 190 Newton per millimeter square. So what I'll do is that I'll write 190 is equals to, what is the load applied? Load applied is 50 Newton. As you can see, it is 50 kilo Newton. So what I can do is I can write 50 into 10 to the power 3 pi by 4 into D square. Now D is equals to root over D is equals to root over 4 into 50 into, let me get it zoom, 10 to the power 3 by pi into 190. Now let me clarify you why I have written 10 to the power 3 in terms of load, because 50 into 10 to the power, because it is in kilonewton and I have to represent it in Newton. That's why I have written Newton. Now what would be the value of D? Can anyone tell me how much will be D? D value koto? Just give me the value of D. How much will be D? Because it's an important question. This type of question will come in your exam also. What is the value of D? Fast. কেউ ক্যালকুলেট করছো তোমরা? হ্যাঁ, কত এসেছে?
18.30.
18? Are you sure?
আরেকবার করছি।
দেখো তো eighteen point
18.2.
18.2. So now 18.30 and 18. So that means both are I got answer of 18.3. Let me take the 18.3 or 2, whatever is in. Now if you take 18.3 also, if you consider 18.2 also, now this depends on the calculator, that will not make any sense. Why? Because it's not a multiple of 5. So what I can do, as I have told you earlier, I think I have told you earlier about the assumption. Did I told you about the assumption? আমি বলেছি যে শ্যাফটের এটা কি করে অ্যাজিউম করতে হয় সেটা বলেছি কি আগে?
হ্যাঁ স্যার যে 5 এর 5 এর মাল্টিপল নিতে বলেছে।
Yes, I have to go for next multiple of 5. So what would be next multiple of 5? Can anyone answer me? What is the multiple of 5?
20.
20. That means the
20.
diameter. Yes, that means the diameter of the of the shaft should be 20. So as we know, this D is related to something. So what I can do is that empirical, I could write empirical relations. What are the relations? You have to remember. What are the relations? D1 is equals to 1.1 times 1.1 times of D. A is equals to 0.0.75 times of D. B is equals to 0. Sorry. Is 1.25 times of D. Now can anyone tell me the value? Can anyone calculate the value for me? What would be this one? 1.1 into 20. This will be 1.1 into 20. This will be 0.75 into 20. This will be 1.25 into 20. So I need the value. Please be fast.
22,
Okay,
15 or 20.
22.
Two.
22 millimeter. Next.
15.
15.
Yes, sir.
15 millimeter.
20, 25.
25. 25 millimeter. Very good. Now we have this value from D. So this is not the end. This is just the starting of this one. Now what I can do is the next part is the diameter of D. Diameter of pin, which is considered as small d. Fine, which is considered as small d. What you can do, you have to make one table. You have to make one table. What would be the table? Just I am showing you. So at first you have to write type, next you have to write D equals to, third you have to write approximation. Now what you will do, let me tell you one thing. First you will write shear, SHEAR, shear. Second you have to write the compressive. Let me write it in compressive I. Compressive I. Next you have to write compressive double I. Next is the bending. Note, you don't have to derive it. You don't have to, you just to find out the value. Now, as we know, let me first go for the shear, then we'll put all the values and we'll find out the which will be the optimum value of D, and final value of D, which will give us the actual answer, which will give us the actual answer of how to, which value of D is suitable, which value of D is suitable for our drawing. So what I can do is, let us go for the shear, SHEAR, shear. What I know about shear is that it is given that tau is equals to P by 2 times area. So what is P? P is P, as I know, 2 into pi by 4 into d square, where tau is 95 and P is 50 into 10 to the power 3, 2 into pi by 4 into d square. Find out D is equals to how much? D is equals to how much? This একটা মিনিট আমার জাস্ট এটা stop sharing. So tell me what would be the value of D? Just give me the value of D. D কত?
Sir, 18.3 years.
Okay, fine, not an issue. 18.3 millimeter. So let us go over there. Let us go back to the table and let us write over here the value of D. We have got 18.3 and we have approximated to 19. Fine. So it is okay. Fine. Next is compressive I. Next is compressive I. COMPRESSIV. Compressive I. So what I can do is that for compressive I, we can actually draw, we know the formula. The formula is sigma C is equals to, it's for I, single I, P by B into D. Now what is the P? P is 50 into 10 to the power 3, 10 to the power 3, and D is and D is, we don't know about D. About B we know. From where we know? We have calculated the magnitude of B. What is the magnitude of B? B is nothing but 25, what we have calculated. Fine. Let us go over there. Is 20, just 25. Now sigma C is how much? How much we know that? What is the magnitude of sigma C? The sigma C is, let us go back and see. Sigma C is 190. So what I'll do, what I'll do, 190 is equals to 50 into 10 to the power 3, 25 into D. D is equals to how much? D কত? Everyone be fast.
10.526.
10.526. 10.526 millimeter. It is, let us go back and let us write this value. 10 point 10.526. So let us assume it to be 11. Fine, it would be fine. Now next for the double I, the same thing. This the formula will remain same, just there will be a slight change over here. It will be slight change over here. The other thing will be same. So what will be for compressive? You have to do write and show me. You have to write all the steps. Compressive double I. What is the formula? Sigma C is equals to P by 2A into D. Now what do we know that sigma C is equals to 190, if I am not wrong, 190, 190, 19, oh just give me a sec, 190 is equals to P is 50 into 10 to the power 3, 2 into how much is A? Let us go and observe. Let us get what is the value of A. A is, I think, remember 15. Okay, fine. A is 15. Okay, 15 into what is D? We know D. No, we don't know D. Let us get what is the value of D. D is how much? D কত?
8.771.
8.771. Okay, fine. Always remember to write the unit. Don't miss it. It's very important. How much it is? 8.771. So let us assume it as 9. Approximate as 9. Last but not the least is bending. Is bending. Okay, the value, can anyone see the formula of bending? Can you see the bending formula? It's bit big, but can you see or not? If you're not, okay. Sigma B is equals to 32 by pi dq and B by 4 plus A by 3 into P by 2. Can you see the formula? Can you see the formula? Yes or no? Bending stress formula?
Yes, sir.
Okay, fine. So what happens is that we know that B is equals to, let us go for the practical thing. We know B is equals to 190 is equals to, we know 32 pi by d cube, and we know B is equals to 25, if I am not wrong it's 25 by 4 plus, and A is 15 by 3, and the load applied is 50 into 10 to the power 3. Please find out the value of D and tell me what would be the value of D. Take your time. Within 2 minutes you can get the value. Be fast. Pele. What is the value of D? It's very big calculation, but it's not so much big.
$24.7.
24.7. I need one more person to, because 24.7. Okay, fine. Anyone? Any more? কেউ বলতে পারবে?
sir, 24.63.
Okay, fine. 24.7. Perfect. Now আমি আবার ভুল করে আমি ইউনিটটা লিখে নিই 24.7, that is bending we are getting 20, for bending we are getting 24.7. Now we can approximate in 25. Now tell me, here comes the point of concern. Which is maximum? Which value is maximum among these things? Which one is maximum? The bending one, compressive one, shear ones. As you can see the magnitude. So which one will you consider? Because you need the highest safety of the design. Which one will you consider? Which one will you consider? Just a sec. My tell me, which one will you consider? This one, this one, this one, this one. Which one will you consider? Answer me, anyone. Which one? কোনটা কনসিডার করবে? Let me tell you, I'm not getting any feed from you people. So let me tell you the maximum one, max. So what is maximum? This is the bending one. So it is so what you will be doing, you will be writing 25 millimeter will be the value of D. So you may ask me, sir, we can actually see after doing some after doing some problem that every time we'll be getting the value of bending to be the maximum. So why am I not considering, why am I not doing directly the bending? Because that may also happen that among these three also I may get the maximum bending diameter, get the maximum diameter. So at that point I have to consider over there. So that's why to eliminate any type of confusion we have to draw conclusions from the four factors. One is shear, another one is compressive stress in I, compressive stress in double I, and last but not the least it would be the bending. Now let us go back to the board. Now as we know that we have to again go back to the board and we have to find the empirical relations. Empirical. Just give me a sec. Empirical relation. So what would be the next empirical relation with D? So what is that? That D naught is equals to D naught is equals to sorry D naught is equals to 2D D naught is equals to 2 times into 25 is equals to 50 mm. Now as we know that D naught is equals to how much? Last is right now this is the last position, last part where we'll be verifying. This is called verification. Now verification, the verification starts with I end, single I end. As I have told you in the previous class, in the today's previous class, for we will be considering in two types. One is tensile, one is shear. This would be shear, and one is tensile. So what will happen is that we know that in tensile tensile load we know the sigma t. Don't write sigma t, write sigma t dash. So what we will be doing is equals to P by B into d naught minus d. D naught minus d. D naught minus d. So what would be sigma t? Let us find out what would be the sigma t. What is the load given? It is given 50 into 10 to the power 3. What is B? We know what is B, sigma dash, sorry. What is B? B is 25 as I remember. D naught is 50 and it is 25. Tell me what would be the value. Koto hobe? Tell me what would be the value. Find out the value. Be fast and find out the value. What would be the value?
80.
80.
80. Okay, very good. 80 Newton per millimeter square. Fine. Now, similarly, for shear end, what we know that the formula remains same, because we have seen that mathematically we can find that P is equals to just give B d naught minus d naught. Fine. So even here we can find, because the formula remains same, as you can see this formula and this formula are nothing but the same thing. But so what I can write is that, let us go back, tau is equals to also tau, don't write tau, write tau dash. Tau dash is equals to 80 Newton per millimeter square. Now here comes the moment of truth. Now how can you say this value is safe? How can you say the value is safe? So for that you have to compare. You have to compare in this manner. Now you can see that, let me draw a conclusion that sigma t is greater than sigma t dash, as well as tau is greater than tau dash. Am I right or wrong? Now observe, this is sigma t and this is the value 80 kilonewton, and for the tau dash also it's 80 kilonewton. But as per the calculation what we have done in the earlier segment, we can see that this is what, let me so as per the earlier calculation we can see this is 190. Sigma c maximum allowable is 190, that is it should not exceed this one 190, and tau should not exceed 95 kilonewton per millimeter square. But as you can see over here it is less than 190 as well as it is less than 95. So can I tell that the design is safe? Did you get my point? Can I say that the design is safe? Yes or no? বলতে পারি কি বলতে পারি না? বুঝতে পেরেছো কি বুঝতে পারোনি সেটা বলো। এতটুকু অবধি বুঝতে পেরেছো কি বুঝতে পারোনি? বলছি আবার আমি বাংলায় করছি। এটা 80 কিলো নিউটন, সরি এটা 80 কিলো নিউটন, এটাও 80 কিলো নিউটন, মানে টাউ আর সিগমা টি 80 কিলো নিউটন। বাট আমরা যদি দেখি, আমরা যদি প্রথমে যখন শুরু করেছিলাম দেখলাম যে আমরা অ্যালাউয়েবল কত দিয়েছিলাম 190 আর 95, মানে 95 ছিল শেয়ারের জন্য এবং সিগমা বি ছিল 190। নাও এখন দেখলাম যে এই দুটোর যতটুকু অ্যালাউয়েবল ছিল তার থেকে কম স্ট্রেস জেনারেট হচ্ছে, মানে কি আমারটা সেফ। তাহলে আমাদের যদি এর থেকে বেশি স্ট্রেস জেনারেট করতো মানে কি এটা সেফ না, এটা ভাঙার একটা চান্স থাকতো। সিন্স এটা তার থেকে কম স্ট্রেস জেনারেট করছে, দ্যাট মিনস ইট ইজ সেফ টু ইউজ। ক্লিয়ার হয়েছে ব্যাপারটা? ক্লিয়ার হয়েছে কি ক্লিয়ার হয়নি? ইয়েস অর নো?
Yes, sir.
হ্যাঁ স্যার।
Okay. Next but last but not the least. Last part is verification
স্যার ওই
Verification.
শিয়ার আর টেনজাইলের ভ্যালুটা ওই টাউ আর সিগমা টিটা যদি সেমই হয় তাহলে ওটা দুটো আলাদা আলাদা করে করতে না,
বুঝলাম না কি বলে,
ইকুয়েশনটা তো সেম।
কোনটা বুঝলাম না, বলো কোনটা।
সিগমা টি ড্যাশ আর টাউ ড্যাশ তো সেম ইকুয়েশন ইউজ করছেন, তাহলে
হ্যাঁ,
ওটা দুবার করছেন কেন?
এই দুবার কেন করছি, এটা জাস্ট শো করার জন্য, পরীক্ষাতে তোমাদের এটা করতে হবে, এটা জাস্ট শো করার জন্য, জাস্ট ফর্মুলা লিখে ভ্যালুটা লিখে দেবে, কারণ কি আমরাও জানি যে এটা এই দুটো সেম, কারণ দুটো দেখাতে, দুটো তো আলাদা আলাদা এন্টিটি, এটা শিয়ার আর এটা টেনজাইল, কথাটা বুঝতে পেরেছো, এটা টেনজাইল স্ট্রেস আর এটা শিয়ার স্ট্রেস, দুটো তো আলাদা আলাদা, কিন্তু বাট হ্যাঁ ফর্মুলাটা এক, সেটা আলাদা জিনিস হয়ে গেছে, ফর্মুলাটা সেম হয়ে গেছে আমাদের ম্যাথামেটিক্যাল ক্যালকুলেশনের কারণে, সেটা আলাদা ব্যাপার, বাট আমাদের এন্টিটিটা তো আলাদা আলাদা, কথাটা বুঝতে পেরেছো কি, বুঝতে পেরেছো?
হ্যাঁ স্যার, হ্যাঁ স্যার।
হ্যাঁ, তো সেই জন্য আমি এটা করব, সেম আমরা এখানেও করব, ভেরিফিকেশন ডাবল I. So what would be for a double I? Same. This will be also for this will also be the same. So what would be the same? Let us go for this one back. One is tensile. Another one is shear. We know the value. We know the formula, that is sigma. Now write sigma double T. Okay, double dash T, sorry, not double T, double dash T is equals to P by 2A D naught minus D. So let us find out over here itself. We know sigma T double dash T is equals to P is equals to 50 into 10 to the power 3. 2 into A is 15 and D naught is 50 minus 25. As well as for tau, the formula remains same, tau double dash, don't give tau, write tau double dash is equals to P by 2A D naught minus D. What would be the magnitude of T double dash also? So let us get the value কত আসে বলো, how much will be sigma double T, sigma double dash T is equals to how much? meter Newton per millimeter square.
66.67।
কত? 66.67, 6.67. Now as you can see, both the values are less than the allowable stress. That means sigma double T dash is less than sigma T and tau double dash is less than tau. That means just give me less than tau. That means the design is entirely safe to use. Safe. Fine. So if you get, now remember one thing, if you get safe over here and if you get safe over here, also over here, that means the design is completely safe. Is it clear to you people? That means the design to certify a design to be safe, these two criteria, this safeness, as well as this should be safe, as well as this part should also be safe. Is that clear?
হ্যাঁ স্যার।
Clear or not? বুঝতে পেরেছো কি বুঝতে পারোনি? Is that clear? বোঝা গেছে কি বোঝা যায়নি?
Yes, sir.
Yes,
Okay,
sir.
fine.
হ্যাঁ স্যার।
So the thing is that if there is a one more if anyone fails to be safe, that means among this 1 2 and 3 4, if any one of them fails to be safe, that means the design will be unsafe. That means you have to redo the calculation and you have to see whether there is an error or you have to change the dimension or not. If the four of them, like if the four of the dimensions, that as you can see, this one, these four of the quantities, that is for sigma double t double sigma dash t tau dash as well as sigma double dash sigma tau dash is less than the reputed given, is less than the given value or not. So let me clear it in this manner, just try to understand. Let me give it in a simple manner. Sigma dash t should be less than sigma t as well as sigma t double dash should be less than sigma t. The same goes for tau dash should be less than tau, tau double dash should be less than tau. If this four criteria is maintained, if this four criteria can be observed, that means these things can be, if it can be observed, then you can certify the design to be safe. Am I clear to you people? Am I clear? Yes or no?
Yes, sir.
Clear হয়েছে ব্যাপারটা? Okay. So the thing is that that's for today. I mean, in the theory class we'll be going for practical class. I'll show something practical and you have to do the assignments of practical as well as for the theory also. I'll be sharing you the one question which you have to give the answer. So after that we'll be ending our session. So give me 2 minutes. Let me go for.
এখন আপনি আবার ক্লাস নেবেন এখন?
হ্যাঁ, আমি ডিজাইন, তোমরা কি সফটওয়্যারের ডিজাইনের পার্টটা তো দেখাতে হবে, আজকে তো সফটওয়্যারের পার্টটা রয়ে গেছে।
4:30 থেকে ক্লাস আছে।
হ্যালো স্যার।
হ্যাঁ বলো।
হ্যালো স্যার,
হ্যাঁ।
বলছি আমাদের 4:30 দিয়ে ক্লাস আছে ডিএস স্যারের।